Hi and welcome. This is the second video for lesson 401 Stoichiometry, Year 9 iGCSE Chemistry. This is the work that I set last week, and what I'm going to do is I'm going to go through the other four examples. Now this is going to be done at a faster pace than the previous video. So what I would suggest that you do is, if you have not seen the previous video, what you need to do is you do need to go back to the previous video and watch it, because this is going to assume that you have been through it and that you understand exactly what the steps are that I'll be taking. So, right, okay, so the first thing we're going to do is we're going to have a look at question number 2, and we're going to use the Skittles approach. So just looking at the reactant side, or left-hand side, you've got 2 sodiums. I'm going to be using red for that. So let's just choose that now. Let's see, I think it's going to be more effective with the spray. So there's 1 sodium and 2 sodiums. Okay, so that means that your sodium number is correct. I'm going to use, let's use this sulfur. So there we go, there's 2 sulfurs, number 1 and 2, because of that little 2 next to the sulfur atom on the right hand side, just below there where my crosshairs are. Now actually, just to save a bit of time, I'm also going to indicate that you've got the sulfur over here and the sulfur over here. That means that you have 2. So that's what is happening over here with this sulfur. You've got 2 over there. I just can actually maybe make it a little bit useful and helpful for you. There's your 2. I'll do that again with the sodium. So if I go back to that lovely red that I've got on the palette here, there's 1 and 2 on the reactant side, okay, and then on product side on the left hand side, you've actually got 1 here, okay. So I'll just go through them one particle at a time, one element at a time. Right, we've got oxygen. I'll pick this light blue one. So on the reactant side, you can see that there's a 3 next to the O. So you got 1, 2, 3, and you've got 2 over here. So that's 1, 2, and you've got 1 over here, which is there. So that 1 is 1 atom of oxygen in the water molecule there. And you got your SO2 there as well. So that's 2. Right, okay, so what are we missing? We're missing hydrogen. So let's use this green for hydrogen. There's 1 over here. I'll just put it above. So there's 1 there, but there's 2 on this side over here. So that's why we've got the 1 there, and we've got the 2 hydrogens there. Okay, let's do a little bit of cleanup. Just make sure that we've got the 3 oxygens here. There's 1, 2, 3. Lovely little Skittles there. 1. I don't know why that one was a little bit far out. Let's just correct that. There we go. 1, 2, 3 on this side as well, bit of spray there, because this was SO2 and H2O. Again, you know, if you want to, you can flip back through the video, pause it. If you're not sure about anything, just whip back and forth on it, and you'll be able to see why it is that I'm making these steps. But as I say, I'm making this at a bit of a pace because I've got to try and fit all of them in at the same time on the space in the video. So let's use purple for chlorine. Okay, there we go. And we had the 2 sulfurs, just missed those out. So let's get over here. There's 1, 2 in this compound. This compound is actually called sodium thiosulfate. It's a very popular reaction, actually. This is actually a reaction that is used in chemistry extensively to track rate of reactions and how quickly reaction rates, how reaction rates change as you change the conditions around them. So it's very useful to get to know this particular reaction. Right, okay, so what have we got here? So what we can do is we can now have a look and see how many of each we actually have, whether it's the right numbers that we've got. So we've got 3 oxygens on the left-hand side, on the reactant side, and they seem to be okay. And so do the sodiums, or do they? No, you've got 1 over here and 1 over here, but so that's 2, but you've only got 1 over here. So maybe we might need to start to multiply this, put a little number called a coefficient in front of this sodium chloride over here. So we're going to keep an eye on that. The hydrogens don't seem to be balanced, and neither do the chlorines. So what we're going to do is we're going to leave the sulfurs. We're going to leave them untouched. We're going to leave the oxygens on this side untouched. work on this side first, work on the left-hand side, because this species over here, the sodium thiosulfate, this only has the oxygen, so we can actually start to multiply these and we won't affect the oxygens and the sulfurs. That's a really, really good thing. And what we could do is we could try and multiply this to get the same number of chlorines as we have sodiums on this side. Okay, so I'm just going to make sure that I go through this one step at a time so you're actually following this. So if we put A2, we multiply that by 2, what we then do is we are then multiplying everything in front of that 2, okay? Everything in front of that 2 by 2. So there you go, there's one. Let's just do it over here, just so otherwise you might think it's a molecule. And then we need to have a purple one. So we're doubling the number of hydrogens, we're doubling the number of chlorines on the left-hand side. Okay, now if we do that, we've obviously got 2 chlorines now, and we've got 2 hydrogens on this side. So we're good with the hydrogens, we're not so good with the chlorines on this side. So what we could do is we could multiply that. Okay, so if we multiply that by 2, now that will also double the sodiums, but that's a good thing. It's a good thing because we actually want to double the sodiums too. Okay, so let's double the sodiums. Okay, that's 1. And we've done this because we wanted to try and double the chlorines. Okay, so there you go. And hey presto, I think you'll actually find that is now balanced. Okay, all right. So I'll just put a 2 over there, because just to make sure it's all consistent, just rub that out. Excuse me, that. Bit of smudge there, rub that out. There we go. Right, and we're good to go. That is now balanced. So the 2 numbers that you wanted are 2 there and 2 there. So when you typed it into the Google quiz, it would have been fine just to put 1, 2, 2, 1, 1, 1. Okay, but obviously if you've only got one molecule or one species, and we don't really need to put the ones in at all because we're chemists, so we're cool. All right, number 3. This one was actually already balanced, so I'm just going to take you through this. Okay, so we got 1 sodium on this side, which is 1 sodium on the product side. Okay, we have let's pick a distinct color, 1 oxygen on this side. And we also have 1 oxygen in the water molecule over here. Okay, I hope you're following this. We got 2 hydrogens on this side. And 2 hydrogens are in this water molecule here. That's why you've got the little 2. Okay, we've only got 1 of those molecules, so it stays as 2. Pick a nice pink. Chlorines, got 1 there, 1 there, 1 there, 1 there. Happy days. Okay, right, let's move on. You look at this and you think, oh, that's a big molecule, right? Don't be put off by it. Okay, so this is C6. That basically means that you have 6 carbons on this side. Okay, 1, 2, 3, 4, 5, 6. If you add those 2 carbons to that 1 carbon, you've got 3 carbons. So I think you can realize that if we've got 3 there and we've got 6 there, what if we just had a way in which we could double both of these? Could that work out? I'll come back to that in just a second, but the answer is yes, it will work out. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens on this side because you've got 1 molecule with 12 atoms of hydrogen in, right? Over here you've got 6 hydrogens, you've got 1 here, and you've got 5, so 1 plus 5 is 6, okay? So again, it kind of hints towards us doubling this up, okay? 1, 2, 3, 4, 5, 6, right? And then finally, you've got the oxygens. Okay, so you've got 6 on this side. 1, 2, 3. That's why I like this example. 4, 5, 6. And you've got 1, 2, 3 oxygens. You've got 1 there. Don't forget that 1 there. And you've got 2 there. So it does look as if you just basically need to double everything up on this side. So if we put a 2 in front of both of those, okay? We do that, then we double everything on this side, okay? We double everything on that side. Now we've already added the number of atoms in each of the products, all right? So if we were to double everything on this side, pretty easy then. We just double everything, right? So there we go. We double the number of carbons from 3 to 6, because there's 4 there and 2 there. Number of hydrogens, yeah, I'm going to go through this, right? 1, 2, 3, 4, 5, 6, because now we have 5 plus 1, which is 6, and times 2, which is 12. So we got the 12. And now your oxygens, 1, 2, 3. Okay, so you got 2 times 2, which is 4, 2 times 1, which is 2, 4 plus 2 is 6. So that one is now balanced. Okay, all right. Okay, I'm going to move on now to the next one. Quick plug, so the channel that you're watching this on is Science Night Plus. Please subscribe, okay, because as soon as I upload any video you can see it on there, and if you can just follow me on Twitter. You don't actually have to be on Twitter yourself in order to follow, and I always put updates there and make it really interesting. Right, okay, so where's my next example? I think my next example, yeah, is up here. So I've been through 3 examples already. Oh, there we go. All right, so final one. We've got, this is respiration. So just very, very quickly, 6 carbons there, 12 carbons there. We've got 6 plus 2 oxygens, so that makes you 8, all right? And then you've got on the right-hand side, you've got 1 carbon, 2 oxygens in this molecule, but you've got 1 over here, which is 3. And then over here, you've got 2 hydrogens. Like I say, if you need to, pause the video, scroll back and play through that again until you get it. All right. So my big tip for this one is make sure that you go for the carbons first, because you've got 6 carbons on this side. So it does make sense, because this species over here does not have any carbons in. If you put a 6 here, you've balanced out the carbons, okay? So if you were to go with that, and now you should be getting hopefully a little more confident with this. If you put a 6 there, oh, that's an awkward 6. Let's go over here. All right, here we go. If you put a 6 there, you've balanced out the carbons, right? Now look at the oxygens, okay? Now look at the oxygens. You've got 6 on this side, plus 2, 8. Now you actually have 6 times 2, which is 12. And then you've got to try and multiply. So it can get very, very hectic very quickly. So best thing to do, go back, skills approach, and this will help you, okay? I'm just going to make it a little tiny thinner. There we go. Right, so start again, right? Because if you start going through this with numbers, it will get very, very confusing very quickly, okay? So here we go. Right, 1, 2, 3, 4, 5, 6, okay? You've only got 1 there, right? And the reason why we're doing this is because we want to try and account for the oxygens as well. You've got 1, 2, 3, 4, 5, 6, 7, 8, and you've only got 3 there, okay? 3, right, you've got hydrogens. Let's work on the hydrogens, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because there's 12 hydrogens there. You've only got 2 on this side, right? Okay, so the hydrogens are only here, okay? So why don't we go for both of these multiplications, all right? So let's go back to the multiplying 6 with the carbon dioxide, okay? So if we were to do that, use the skills approach, now we have, oh, there we go. Now we have 6 carbons on this side, 1, 2, 3, 4, 5, 6. And now we've got 6 times 2 is 12 oxygens, okay? So we go back to the oxygens. 1, 2, 3, 4, 5, 6, okay? If you continue doing that, then what you will find and end up with is You'll find it all balanced if you put 6 there and 6 there. Okay? So good luck with that. Have a look at it and let me know what